Now you will hear a sound that no one on Earth has heard for billions of years. This is not a special effect, not computer graphics, not the work of a sound engineer. This sound was recorded by the microphone of the Mars rover right on the surface of Mars at the very moment when a real Martian wind swept over the red desert. Imagine there are almost 300 million kilometers of space between you and this sound. But how did scientists even manage to hear another planet? And what other sounds do the worlds of the solar system hide?
Luna. So mysterious, alluring, and enigmatic. The only satellite of Earth, its eternal companion. It seems like it has already been studied inside and out. People and probes have landed on the moon. Scientists have already had samples of lunar soil in their hands, and they've even tried to grow some Earth plants there. The dark side of the moon has long ceased to be a mystery, and overall we know almost everything about it. But what questions does humanity still have? What if these questions are actually the most important ones for us? After all, the moon's influence on Earth is much greater than you think. And it's not just limited to its connection with tides and sleeplessness during the full moon, as you might think. What if we try to answer the most important questions about the moon? How exactly did the moon appear, and how did samples of Earth's rocks end up on its surface? Is it really true that without the moon, life on Earth would not be possible at all? And what if instead of the moon, there were other planets from the solar system? Buckle up. We're traveling through time to look at a planet that hasn't seen humanity yet, to witness a cosmic scale catastrophe that may have sparked life on Earth and given us our satellite, and to find out just how important the moon's influence has been on our Mother Earth. Hubble's subscribe first. Let's recall what we know about the moon. The moon is a relatively large satellite compared to the size of its planet. Its diameter is 3,474 kilometers, while the diameter of the Earth itself is 12,742 kilometers. Such proportions are very rare in the solar system. Only Pluto has a truly large moon, but it recently lost its status as a full-fledged planet and became a dwarf planet. As for Earth, planetary scientists believe that the moon stabilizes our planet's orbit, and in particular the tilt of its axis of rotation, which creates the seasons. Some believe that without the moon, the tilt of Earth's axis of rotation could have changed significantly over several million years. This would have led to unstable climate conditions, making the environment less favorable for the development of life. In addition, the presence of the moon increased the length of the day. Let's not forget that the moon, thanks to its reflective ability, provides us with light at night, and its magnetic forces help regulate the level of the world's waters. The Apollo program made a huge contribution to our study of the moon. Samples of lunar soil were brought to Earth, a real treasure trove for those who truly wanted to learn more about the origin of our satellite. One of the most amazing discoveries scientists made in this area was the fact that the composition of this soil strikingly resembled the composition of the Earth's outer rock layers. For example, if you take an element like oxygen and look at the abundance of its isotopes, you can conclude that their composition is almost identical in both lunar and terrestrial soil. But if we try to compare Earth's soil with, say, Martian soil, their composition will be radically different. Another important discovery was that lunar rock is much drier compared to Earth's. It seemed that lunar rock had been exposed to extremely high temperatures and lost elements that could easily evaporate. What could this mean? Could it really mean that the moon was once part of the Earth? Moreover, this suggests that the process of the moon's formation is connected to some extremely destructive event, namely the collision of our Earth with a massive celestial body. Could it really be true, and is that how the moon actually formed? There are several theories about how the Earth acquired its faithful pale companion, but the most likely one is called the giant impact hypothesis for the moon's formation. According to this hypothesis, several billion years ago, an object comparable in size to Mars collided with our planet. Since the impact was glancing, otherwise the Earth would have simply exploded, this object either bounced off into space after hitting the Earth, or it was completely absorbed, sinking into the planet's interior. The fragments of rock and magma that were ejected from the Earth as a result of the impact ended up in Earth's orbit, and over millions of years, they came together to form a single object, which, thanks to its rotation, took on a spherical shape. But what if this collision had never happened? And what if there had been people on the planet at that moment? Let's go back about 4.6 billion years, when hundreds of very young planets began to form around a new star, our Sun. Among them were the tiny Venus and Earth. Their trajectories were very different from what they are now. They were more chaotic, so collisions were bound to happen. Imagine a race with no rules. A bunch of cars with different speeds are driving in a circle, in our case around the young Sun. They overtake each other and crash into each other very often. Earth and Venus succeeded in this race. They became real devourers of smaller planets. These planets were similar at the very beginning of their existence. But something happened that made the two sisters completely different. And that something was the collisions with other celestial bodies that Venus and Earth experienced, which essentially changed the fate of the two worlds forever. So two objects crash into Earth and Venus, and both of these impacts have huge consequences for both planets. So what happens? The impact that happened to Earth makes the planet spin faster. It speeds it up. Because of this, a strong magnetic field forms around the planet, which gives Earth protection from most of the solar radiation, and that is what allowed life to develop on Earth in the future. Also, thanks to this impact, Earth gained the tilt of its axis, which caused the change of seasons. Could it be that the same thing happened to Venus, and life could have formed there as well? Unfortunately, no. When a similar object, but larger in size, collided with Venus, its impact not only managed to stop Venus's rotation, but it also caused the planet to start rotating in the opposite direction. Moreover, its rotation is almost 243 times slower than Earth's. How could this catastrophe have affected the future of Venus? The thing is, the planet's rotation speed became insufficient for its core to start generating a strong magnetic field. As a result, the surface of Venus was left defenseless against the deadly stream of particles shot out from the Sun. The hypothetical planet that knocked a piece out of Earth, which later became the Moon, is called Theia. It turns out that the collision between Earth and Theia was the last major catastrophe our planet experienced. Can you imagine what would happen to us if a planet of similar size collided with Earth now? One thing can be said for sure: humanity would have no chance of survival. A wave of fire would completely burn up the atmosphere. The fragments of the two planets would later begin to form a new world, in which there would be no place for humans or any forms of life that had inhabited Earth until that moment. I really wouldn't want to experience such a catastrophe, but in reality we should definitely be grateful to Theia, because without the Moon, life on our planet would be drastically different from what we have now. Many experts even question the possibility of life developing on Earth without a natural satellite with parameters similar to our Moon. This is part of the so-called rare Earth hypothesis, which we will definitely discuss in future episodes. But for now, Let's try to imagine what it would be like if other planets of the solar system were in the place of the moon. In the case of Venus, due to its larger size and remarkable reflectivity, we would have nights comparable to our current early twilight. Besides, Earth's sister is unlikely to become its satellite, as it is simply too large. If Venus moves around Earth at the same speed as the moon, sooner or later their paths will collide, and we will have a new catastrophe. Almost the same applies to Mars. If you were unlucky enough to be on planet Earth at the moment Venus or Mars turned into a natural satellite of our planet, you would have to prepare for various catastrophic consequences: tsunamis, a sharp rise in sea level, and a catastrophic increase in the sunlight reflected by the satellite. Let's not forget about the changes in the trajectories of the two planets. Although in the case of Mars, some specialists allow for the possibility of Earth and Mars turning into a kind of mini planetary system existing in a certain balance without collisions or large-scale cosmic catastrophes. And what would happen if the possible satellite were larger than Earth? Our planet, if it ended up at a short distance from Jupiter, would itself become a satellite of the gas giant. The terrible gravitational force of the giant would destroy our planet, gradually crushing it and capturing it piece by piece. Almost the same fate would await us in the immediate vicinity of Saturn. So we should be glad that it is our small and cozy moon that is next to us. What else has it done for Earth besides the very fact of its appearance? Surprisingly, there is an opinion that the satellite of our planet made a decisive contribution to our very existence, and it's not about the catastrophe that made the Earth spin faster. How exactly? Do you remember that the moon is responsible for the tides of the world ocean? Scientists believe that the tides gave an impetus to the emergence of life on Earth. When substances present in the early oceans mixed with water, special conditions were created in the tidal zone. Then the water evaporates under the influence of the sun. During high tide, the water would return and flood the rocks. In these conditions, on the wetting and drying of rocks, something began to form that much later would become life. Under such conditions, very complex molecules appeared from simple substances. RNA, one of the fundamental components of living cells, could have first arisen thanks to tides controlled by the movement of the moon. The tidal zones were real chemical laboratories of that time, laboratories where life itself was being created. It may sound silly to a modern person, but after learning so many remarkable facts about our closest neighbor in space, it's not surprising at all that for centuries the image of the moon has been deified and celebrated in the culture of world civilization. But even now we can look at the lunar disk or crescent with gratitude and curiosity. After all, who knows how many wonders are hidden in this mysterious celestial body, so close and yet so far away at the same time. Congo and neighboring countries. We are constantly being frightened by all sorts of disasters, and they claim that the Earth, as the cradle of humanity, is literally on its last legs. But we suggest not to panic, and instead to pay attention to the other planets of the solar system, of which there are 7 besides our own. We have to give credit to Earth's astronomers. All this time they haven't been sitting idly by, but have been actively trying to study our neighboring planets using modern equipment and probes. And gradually they even reach the insanely distant misty Uranus. But it's a gas giant without a solid surface to land on. Besides, it's completely frozen, you might argue. So what? As the hero of a famous movie once said, there are no obstacles for patriots. Let's look at Uranus through the eyes of Voyager 2, the only probe to have visited Uranus's vicinity. So what is this bluish, perpetually sideways, frozen gas giant like? This world is as different from ours as a basketball is from a sea urchin. It's very cold on Uranus. If you settled there, you would have to endure a temperature of minus 224 degrees Celsius, and also get used to the fact that there would never be any ground under your feet. It would be like living among the clouds. The states of matter here do not have clear boundaries. The gas gradually transforms into a liquid, and then the liquid, in turn, becomes something resembling a solid. On the planet, the smell of hydrogen sulfide and ammonia is everywhere, like rotten eggs and urine. Uranus is 60 times larger than Earth. Here, winds blow at a speed of 824 kilometers per hour, and there are almost constant thunderstorms that could outdo all the ones on Earth combined. It's not the nicest place, only if you're into that sort of thing. Add to that a 42-year-long winter and other seasons of the same length. No wonder the planet was ignored for so long, right? But in 1986, a NASA probe called Voyager 2 did fly by Uranus. And although the visit was just a flyby and the encounter was rather brief, the probe managed to photograph the Uranus system along with its rings and closest moons. Uranus in false color. The outer ring of Uranus. Miranda Uranian moon. Colors of Uranus. True color on the left and false color views of Uranus. January 17, 1986. Distance 5.7 million miles. Three moons discovered by Voyager. 2, 1986. U1, 1986. U3, and 1986. U4. January 18, 1986. Distance 4.8 million miles. Oberon. The best image of Oberon shows craters and a large peak on the lower limb of the moon. January 24, 1986. Distance 410,000 miles. The ring system. A rear view shows a continuous distribution of small particles throughout the entire ring system. January 24, 1986 range, 147,000 miles. When project manager Edward Stone summed up the interim results of the mission, he said that no probe had ever seen a more unusual system. Scientists were especially amazed by the so-called magnetic tail discovered by Voyager 2 near the ice giant, as well as the landscapes of Miranda, one of the planet's closest moons. In the photos sent by the probe, it is clearly visible that for unknown reasons, the Uranian moon became an incredible mix of different worlds. Martian valleys and channels, the deepest Mercurian faults, Ganymede's grooves, and monstrous lunar craters. At least 10 types of terrain have merged here. Also, among other things, the spacecraft analyzed Uranus's atmosphere in passing, discovered 2 new rings, and found 10 previously unknown moons. As they say, it did everything it had time to do. But why hasn't any other spacecraft visited the giant since then? The unfortunate situation happened for the same reason as with distant Neptune. The location being explored is not incredibly far away. First of all, with the current level of technology, a flight to Uranus would take at least 15 years, and would involve multiple gravitational maneuvers. Secondly, no solar panel would work at a distance of 3 billion kilometers, since Uranus orbits 20 times farther from the Sun than Earth. That means we would have to use a nuclear power source, which is much more complicated and expensive. The next problem is adequate data transmission. After all, there's no point in sending an expensive and lengthy expedition that will send back photos to Earth with last century image quality. Therefore, it is quite logical to ask about equipping the Uranian station with a huge antenna and building a gigantic receiver on Earth. And the last obstacle is the team of specialists overseeing the flight. After all, during this time, the number of staff members could very well decrease. And we haven't even started discussing the equipment for the probe yet. In short, the task ahead is extremely difficult, but achievable. Now, the main question: why are these incredible efforts necessary, other than to understand the principles of the formation of ice giants and their systems? But there are reasons, and they are compelling. First, the extraction of valuable resources, and second, the possible colonization of the planet. Yes, you heard that right. A celestial body without a surface can be settled by human colonies. So let's start with factories for extracting helium-3, an element found in abundance in Uranus's atmosphere. How can this plan be carried out? First of all, a base should be built on one of the moons. Then, it is necessary to send an army of remotely controlled robots to Uranus, which will pump atmospheric streams, filter them, run them through centrifuges, and liquefy them. To carry out the process, most likely a drifting base will be created, powered by thermonuclear fuel and located directly in the Uranian atmosphere. Considering the escape velocity on Uranus, which is the lowest among all the giants, transporting cargo will surely not be problematic. No matter how much we use robots, it is unlikely that such an operation could be set up and launched without human involvement. Therefore, the question of organizing colonies naturally arises. But where can this idea be implemented besides satellites? After all, there is no surface on Uranus. It's elementary, right there in the atmosphere. For example, if you fill huge balloons with hydrogen, they could keep entire cities afloat, and the gravity here would be similar to Earth's. To carry out even a part of these ambitious plans, it's necessary to launch at least one more mission in this direction to start with. NASA has been talking about such a project for a long time, but because it's so expensive and still unfinished, the process keeps getting postponed. Meanwhile, the next launch window for a mission to Uranus is between 2030 and 2034. Under these conditions, the travel time will be about 12 years. But if everything goes as planned, the world can expect a whole bunch of sensational discoveries. That much is certain, because the Uranus system is one of the least explored locations. It would seem that 54 years have passed, but the legendary mission of Neil Armstrong, Edwin Aldrin, and Michael Collins is still well remembered. And, as you can imagine, that flight was a very, very long time ago. During this time, space science has advanced a lot, and modern technologies truly work wonders, especially in the field of exploring the vastness of the universe. However, just think about it. The last manned mission to land on the moon was in 1972. So why aren't there any flights to Earth's satellite now? What is the main reason behind this? Surely the first things that came to your mind were various conspiracy theories, that the moon landing was actually filmed in a movie studio, that it's the biggest hoax in history, and so on. In this video, we won't be discussing those theories, but we will say that they all boil down to one question. If moon landings were successfully carried out before, then why can't it be done now in the age of modern technology? Unfortunately, it's not possible to give a short answer to this question. The situation is far from as straightforward as it might seem to conspiracy theory enthusiasts. First, we need to understand the historical context in which the idea of landing a human on the moon originated, and how such a plan was eventually carried out. As you may recall, this was during the height of the Cold War, which in the 1960s took the form of a space race between the US and the USSR. It was the latter that managed to pull ahead. First, the Soviet Union created the first artificial satellite to reach orbit, and then sent the first human, Yuri Gagarin, into space. Assessing the situation, the United States thought they needed to do something bigger to get ahead. They decided to land a man on the moon. As you can imagine, the United States was driven primarily not by research motives, but purely political ones. And so the astronauts landed on the moon, points in this race were scored, and accordingly, interest in all of this gradually began to decline. NASA felt this very clearly. Their budget was severely cut. Because of this, future Apollo missions were put at risk. Each such mission required more than $1 billion in funding. Thus, the number of missions began to decrease, since in fact, no one was really interested in them. A significant role here was played by the lack of motivation to be first, to outplay some other country, since by the 21st century, the US practically had no strong competitors left in the space industry. That's how it turned out that further manned landings on the moon lost any real meaning, as sad as it may sound. Even now, NASA finds it financially difficult to pull something like that off. Usually, developing a single launch vehicle can cost, let's say, $50 to $60 billion, while in 2022, NASA's budget was $24 billion. And as you can imagine, compared to that, it's not very much. Here's another question. There's the lunar module and there's the rocket. So why can't they organize a landing with all of this? In fact, there's no need to invest in creating these vehicles from scratch. The thing is, both the lunar module and the rocket were developed in the 1960s for the Apollo mission. These technologies are no longer relevant after many years. The technological process that allowed these objects to be maintained has changed a lot over this time. Accordingly, ensuring safety is problematic. And nowadays, there aren't as many specialists who could work with programs from the 1960s. Now, designing models and rockets using modern technologies is the most optimal option and requires a relatively smaller budget. The moon now plays a slightly different role than it did in the 1960s. Back then, it was seen as one of the tools for achieving political goals. Now, it is one of the main objects for scientific research. A huge number of missions are being organized to the moon. For example, the Chinese automated interplanetary station Chang'e 5 collected samples of lunar soil in 2020. There is also very good news for us. NASA is planning to land a team of astronauts on the moon by the end of this decade, and the crew will include the first woman. This is Christina Koch, and she holds the record for the longest spaceflight among women, 328 days, 13 hours, and 58 minutes. In April 2023, NASA introduced her as one of the crew members for the Artemis mission. Koch will serve as a mission specialist. As part of the Artemis 2 mission, a flyby around the moon is planned, while the goal of Artemis 3 will be a direct landing on Earth's satellite. After that, NASA plans to pursue even more ambitious plans. To create a kind of research station where it will be possible to stay for an extended period of time in order to conduct various tests, experiments, and so on. It should be noted that they wanted to send astronauts to the surface of the moon as early as 2024, but in 2021, after serious discussions, they decided to postpone such a large-scale mission. The pace of preparation did not match the established deadlines. As a result, we got a new date, the year 2028. Meanwhile, they got orders from the White House to speed up. In recent years, Americans have begun to show increased interest in the moon, and in general, a desire to revive the spirit of those times when people watched with bated breath as the first crew landed on the moon. Let's return to the Artemis 3 tubs. As part of the mission, it is planned to land a spacecraft with astronauts in the area of the South Polar region. The astronauts will have to conduct research and carry out 4 extravehicular activities directly on the surface of Earth's satellite. The main goal is to study the terrain, conduct various tests, and collect samples of water ice, which is quite a challenging task. Before starting such a high-stakes mission, it was necessary to conduct 2 training flights so that everything would go smoothly during the actual flight. The first test flight took place in 2022, and the second is scheduled for 2024. If the first flight was conducted without astronauts, then a year later they will be on board. The progress of mission preparation is positive now, since NASA is working at an accelerated pace. The Artemis mission's descent module needs to be fully built 2 years faster than the usual time frame for creating similar modules in other missions. The design of such an object is even more complex since it is required to successfully transport astronauts to the moon. Obstacles in the way of Artemis have included insufficient funding in some areas and the coronavirus. How quickly preparations for the mission will be completed depends not only on the work done directly on it, but also on how successful other NASA projects related to lunar exploration, such as orbital stations, will be. Some projects, such as the development of the launch vehicle for the Orion spacecraft, are experiencing delays. We hope that in a few years we will watch the progress of the mission with bated breath, with pleasant excitement, just as people did in the past century. And what do you think? How soon will astronauts land on the moon? And where will we be able to watch the live broadcast? Time, an absolute value. That is the opinion of the overwhelming majority of physicists. But can we trust this knowledge? Are they reliable? Let's try to figure out this complicated question. Since childhood, we've been used to dividing hours into minutes, which in turn are divided into seconds. We grouped months into years and decades. It seems to us that around the house there are trees, cars, people, the starry sky, and nothing else remarkable. But all of this slowly and smoothly floats along the invisible, eternal river of time. But is it really eternal? When will the end of time come? And what will happen after that unimaginable event? Many writers have tried to predict what might happen if the laws of time were stopped, slowed down, or reversed. A work called The Clock That Went Backward by Edward Mitchell inspired a Hollywood film about the unfortunate Benjamin Button, who was born an old man and died an infant. Touches on the idea of what would happen if people could influence time. Herbert Wells continued this theme in his famous novel The Time Machine and the short story The New Accelerator. Obviously, nothing good came out of this, since human knowledge of time is ridiculously limited. But even in their boldest dreams and fantasies, writers did not dare to stop time itself. They only imagined machines that traveled along the space-time continuum, or incredible potions that dull the sense of time, essentially tricking the brain. According to classical physics, time flows evenly and eternally. Only the motion of objects changes in terms of their acceleration or deceleration. The time scale is represented as a coordinate axis with points representing moments. Throughout their short lives, people sequentially move from one point to another, and no one has ever managed to break the established order, except for wildly imaginative science fiction writers. As for the laws of thermodynamics, they are very particular about defending the direction and orderliness of time. To exaggerate the issue, scientists imagine time as a bookshelf that could one day collapse. If it gets filled chaotically, restoring order won't be difficult. You just need to put the books back. But if the books were arranged by color, the task becomes more complicated. If you add parameters like size, year of publication, author's last name, and so on, then arranging the books becomes a very difficult task. That is, If the temporal order is disrupted according to fans of thermodynamics, it will be extremely difficult to restore it, but not harder than leaving a like under this video. Time was flowing long before the birth of the first star. It will keep flowing smoothly even after the death of our galaxy, but what will happen if it stops? Is it possible? We are used to thinking that the universe, like time, is infinite. When people say this word, they don't fully understand its meaning, because in our world, everything has a beginning and an end, and a person simply has nothing to compare this unimaginable concept to. Although one thing can give a vague idea of finite infinity. Is it difficult? Actually, the example is extremely simple. This is a sphere. If we try to find its boundaries, it's pointless from the start, so in terms of limitation, it is infinite. But at the same time, its surface area will always have a finite value. Perhaps it's exactly the same with the space-time continuum. There's a hypothesis about time freezing to illustrate the universe's final days. One of the apocalypse theories suggests that perhaps time will stop, and an endless sequence of moments will turn into a single one, frozen forever, like in an old photograph. It will last forever. Everything that was supposed to happen to you will definitely happen many times. There will be no old age, no death, only one endless moment. From a human's point of view, it will seem like immortality contained in a single drop of time, which is eternal. The paradox is that a person won't even realize that time has stopped. In the meantime, we can endlessly measure this quantity that we don't fully understand, because that's the only thing people have left. After all, you can't taste time, you can't break it down into atoms, you can't study it under a microscope. We break it into fragments, call them seconds, and imagine that nothing can surprise us anymore. It's like a first grader, confident after reading his first syllable, thinking he understands everything. Let's hope that humanity will become more and more knowledgeable over time. After all, there is still so much unknown and unimaginable left to discover. Please support us by subscribing to our channel and community page. Links are on screen and in the description. The future of the channel depends only on you. Subscribe.